Okay, so let's review our exam 2. We're given those formulas. I just want to, probably we're using them in our questions. Okay, let's say the first question. It's worth 16 points. So we have 2 parts. So first we find for the union, intersection, then A complement intersect B. So 3, 4. Then find A intersect with B complement. So this is the first part. The second part was second find. Find the cardinal number of each set. And so many of you forgot to do the second part, given the cardinal number of each set. All right, some of you use the abbreviation. That's perfectly fine. So let's do the first one, A union B. So A union B. So for union B, think about united them together. So every element in either one has to be in this union. Okay, we have avocado. Right? Maybe we use A. We have a banana. Maybe we use B. We have a mango. Maybe we use M. We have a coconut. Maybe we use C. We have cucumber. That maybe we use CU. Then we have a pineapple. We use P. Grapefruit. We use G. Then passive. Right? Passive. It's better to write everything out. For me to save some time, just going to abbreviate. So passive, then pensive, then pineapple. Well, pineapple we have already. This P represents the pineapple, so we don't have to repeat. Remember the elements in the set has to be distinct. So the next one will be post. Maybe use PO, then purple. Right. Then we need to find the cardinality or cardinal number of this set. So count how many distinct elements we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So just write down 11 on the side. So I know you mean the cardinal number. So that's first one, right? A union B. Now, second one, A intersect with B. That means the element in A also in B. The only pineapple, right? Only pineapple in both. So just write on P or the pineapple. Intersection, so the only one element. So write 1 on the side to indicate that it's a cardinal number. Now 3. We want to find A complement intersect B, which means the element in B but not in A, right? A complement means not in A. Intersect with B means the elements in B not in A. So we have passive, pensive, or pineapple is in A. So post and purple. So 4 elements. So that's A complement intersect with B. Now let me write here. So 4, A intersect with B complement, which means the elements in A but not in B. Not in B, but only pineapple in B. So we need to write down all the rest in A. Avocado, banana, mango, coconut, cucumber, and grapefruit. How many? 1, 2, 3, 4, 5, 6. So that's 6 on the side to indicate its cardinal number. And that's it. That's the first one. If you did all this, you get full credits, 16 points. If you get a partially right, partially wrong, the partially right, you still get credits. Now let's see second one, 6 points. An experiment is performed where a participant selects 3 marbles. Let me use blue color. Actually, let me erase the rest. You can always go back to watch it. So let me erase them. Now we're looking at the second one. Second question. So we want to select 3. So this 3 is very important. Right. So let's mark the important word. So select 3 marbles from a bag of marbles containing 4 red, 3 blue, and 2 white. So how many in total? So 4 plus 3 plus 2. We have 9 in total, right? So identify the sample space. Okay, we want to identify the sample space. Let's see. This question actually is a little bit tricky because we didn't really have any example to, reflect this anyway. So we have red color, we have blue color, we have white color. So the first marble we could have, right, the possibility is to get a red one, or get a blue one, or get a white one. Right, so the 3 possible. Remember, what is a sample space? Sample space means all possible outcomes. All possible outcomes. So for the first marble, the outcomes can be red, can be blue, can be white. What about the second one? If we draw the first one to be red, the second one still can be red, or maybe blue, or maybe white, right? Or maybe we draw the second one to be blue. So the second one could be red, or could be blue, or could be white. If we draw the first one to be white, the second one may be red, maybe blue, or maybe white. Then the third one, the third marble. The third marble, let me use red color. If the first one to be red, second one to be red, then the third one could be red also. Or can it be blue? Yes, because I have 2 blue. Because I have 2 blue, I have 3 actually. I have 4 red, 3 blue, and 2 white. Right? So it can be blue, and it can be white. Right? So the third draw. So basically, I could have RRR, RRB, RRW. Well, if the second one is blue, right? The first one is red, the second one is blue. So the third one can be red, can be blue, or can be white. If the second one is white, the third one can be red, can be blue, or can be white. Because I have 2 white marbles there. Then if I draw the first one to be blue, the second one to be red, then my third one can be red. Also, let me write down, I don't think I have enough space, so I'm gonna write vertically. So my third one can be red, can be blue, also can be white. If my second one to be blue, my third one can be red, but can I be blue anymore? Oh, it still can be blue because I have 3 blue, and can be blue and can be white. So if my first one is blue, second one is white, my third one can be red, can be blue, and can be white also. Right? So if my first one is white, second one is red, my third one also can be red, can be blue, and can be white because I have 2 white. Right? So if my first one is white, second one is blue, my third one can be blue, can be red, can be blue, can be white, can be any of this. If my first one is white, second one is white, my third one cannot be white anymore because I only have 2 white. But I still can have red, I can have blue. So how many outcomes there? If we want to write on the side, let's write on the side, use blue color. So sample space. So the sample space, we have red, 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 right? We can have red, 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 blue, red, red, white. The first one. Then this three. I need more space, so let me erase this. So that's this three. Oops. That's this, right? First one is red, the second one is red, and the third one could be red, it could be blue, it could be white. Then I can keep going. I could have red, first one, second one to be blue. Then I still have three choices, which is this. Have red, blue, red, red, blue, blue, and red, blue, white. Red, blue, white. Right? This. Then the second one could be white. So I could have red. My first one is white, red. My second one could be white. Then my third one can be red, can be blue, and can be white. So we finish this one. So first one to be red. So the first marble to be red. So second one could be red, could be blue, could be white. And each one we still have three possible choices. So now leads to the blue one. So the first one is blue, the first one is red. So I could have first one red, first one blue, third one blue, and first one blue, second one red. I could have third one white. That's this one. Right. So just keep going. I could have blue, blue, red. Because I have three marbles, so I could have a blue, blue, blue. I could have a blue, blue, white. That finishes this one. Then I could have a blue, white, red, blue, white, blue, and blue, white, white. Right, that finishes this one. Then for the third one to be white, I could have white, red, red, white. Second one to be red, and the third one to be blue. First one white, second one red. I could have third one to be white. Right, that's this one. Then I could have first one white, second one blue, third one blue red. Then I could have WBB or WB white. That finish this. So then I could have white, white, red, white, white, B. Then I add all this up. So how many I should have? Just count the red color. Red color I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I have 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 3, 7, 3, 8, 3. So 8, 3, 3 times 8, 24, then 25, 26. So the sample space should be 26. The cardinal number. So the sample space cardinal number should be 26. There are 26 of them, right? If you count, we list here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6. So 26, the cardinal number of the sample space. Okay, that's the second question. Now I need to erase them to give me space. Okay, let's see the third one. The third one, we give a set contains A, B, C, D, 4 letters. We will ask how many subsets we have. Remember, subsets related to 2 is 2 raised by the cardinal number of the set. So since we have 4 elements in the set, means the cardinal number is 4. So the subsets, how many subsets? There's 2 raised by 4. Many subsets. What's 2 raised by 4? 2 times 2, 4 times. Right. So L has 4 elements. So the cardinal number is 4. So the subsets is 2 raised by 4, which is 2 times 2 times 2 times 2, 4 times. Well, 2 times 2 is 4. 4 times 4, 16. How many proper subsets? Remember, only the set itself is not proper. The rest of the sets are proper, means has less element. So only 16 minus 1, so 15 proper subsets. So this question is pretty simple if you know how to do it. Now let's see 4. So 4 worth 6 points. So a given universal subset is A, B, C, D, E, F, G until Z, so 26 letters. Then the subset A is given as a T, R, O, U, B, da, 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 da. So we want to find the complement of A. And then find the cardinal number of complement of A. So with this, actually, it's very easy. Because what can we do? We just do this. We want to find the A complement, which means the elements in U in the universal set, not in A. Okay, so let's write down A complement here. But first, we're going to use U and A here, not in A. So we just cross off. So T, right? T is in A. And the R is in A. O in A. U in A. B in A. L in A. E in A. M in A. A in A. K in A. I in A. N in A. N. G, S. Okay, now just write down the rest in U in the A complement. So I say C, I say D, I say F, I say H, I say P, I say Q, I say V, W, X, Y, Z. So what is the cardinal number of A complement? Count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, if we want to make sure, we just count how many elements in 8. 1, 2, 3, 4. Well, let's cross out this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14. So the cardinal number of A is 14. Do we have 26 characters in here? Maybe I missed one. Because if this is 26, 14 plus 11, I only have 25. That means I missed one. Well, let's try it. So A, B, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, that means I missed one, right? I missed one. This is 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14. But I only got 11. I should have 12. So that means I have missed one. Well, let's see. A is here. A, B. Oh, I'm missing. Oh, B is here. A, B. C is here. D is here. E. F. F is here. A, B, C, D, E, F. G. H. I, J. Oh, I'm missing J. You see, only I here. J is not in A. So J should be here. So the cardinal number of A complement is 12. It's 12. Okay, so it's very important to check our work. Right now, I have 14 elements in A and 12 elements in A complement. They do add up to be 26 for the universal set. So I know I did it right for A complement. Now let's see 5. 5 is a calculation. Remember A factorial, 16 factorial, right? Means A times 7 until 1. Well, we need to do the parentheses first. So let's write down A factorial, 16 factorial. Then the denominator will have 4 factorial. 15 minus 3, we have to do this first. We have to subtract. 15 minus 3, you have 12. 12 factorial. Then 5 factorial. Okay, now we want to simplify it. How do we simplify? So 16 factorial can be written as 16 times 15 times 14 times 13 times 12 times 11, so on, but that's 12 factorial. So n that's 12 factorial. Why? Because I have 12 factorial in the denominator. So same way, we want to write A factorial as A times 7 times 6 times 5 times, actually times 5 factorial, because we have 5 factorial in the denominator, right? So we can simplify that. So let's write down. I don't think I have enough space. So I'm going to write on the bottom. So I'm going to write here. So 8, I'm going to write as A times 7 times 6 times 5 factorial. 16, I'm going to write as 16 times 15 times 14 times 13 times 12 factorial. Then divided by 4 factorial. Well, 4 is 4 times 3 times 2 times 1. Then I keep 12 factorial. 12 factorial. Then 5 factorial. Then perform cancellation. In the numerator, I have 12 factorial. 12 factorial in the numerator, 12 factorial in the denominator, because 12 factorial divided by 12 factorial is 1. Something divides itself, always 1. I also have 5 factorial and 5 factorial here. So 5 factorial divided by 5 factorial, also 1. So those are gone. What's left? So I have A times 7. Actually, I can keep simplifying. Let's keep simplifying, actually. With the numerator, with the denominator, we can always simplify. Now, I see 2 times 4 is 8. Can simplify this. Right? 2 times 4 in the denominator is 8. 8 divided by 8 is 1. 8 divided by 4 times 2. That's also 1. So that's simplified to be 1. Then I'm left a 3 here. So 3 times, I can simplify with 6 or simplify with 15. 3 times 5, 15, right? 15 divided by 3 is 5. Now what's left? I have 7 multiplied by 6, multiplied by 16, multiplied by 5, multiplied by 14, multiplied by 13. So now I can use my calculator to calculate this. So just use my calculator. I do 7 times 6, 42, right? Then multiply by 16 times 5 times 14 times 13. So I'm getting a huge number, which is, let me write here, which is 611,520. It's good to do second time, right? To just do one more time, confirm the answer is right. 16 times 5 times 14 times 13. Yes, my second time I still get 611,520. Okay, so that's done for the calculation of the factorials. Now the second one is the B, so B. So B is to calculate this, right? So combination. So that's 12 factorial divided by 12 minus 4 factorial, or 12 minus 4 is 8. A factorial and divided by 4 factorial. So we're going to do the same thing as we did here for the A part. 12 factorial, we want to write as 12 times 11 times 10 times 9 times A factorial, because it can cancel with the denominator, right? 4 factorial, we want to write as 4 times 3 times 2 times 1 and times A factorial. Now, A factorial divided by A factorial becomes 1. So this simplified to be 1. If you want in multiplication, we can ignore it. Then we can keep simplifying. So we say 3 times 4 is 12, cancels with the 12 in the numerator, right? 12 divided by 4 times 3. That's 12 divided by 12, which is 1. Then we have this 2 here. 2 goes into 10 5 times. Right? 2 times 5 is 10, or 10 divided by 2. 10 divided by 2, that's 5. So now we just use our calculator to calculate 11 times 4 times 5 times 9. And what's left? Another 1. Anything multiplied by 1 is still anything. So 11 times 5 times 9, which is 495. Okay, so that's B. Okay, so for A, it's this number. For B, I want to change my color. For B, is this number. Now let's look for C. C, we need to calculate the permutation. I need to erase this. We want to find out of 9, permute 1 element. Out of 9 elements or 9 things, we permute 1. So how many ways of doing that? This one. So that's 9 factorial divided by 9 minus 1 factorial. Well, 9 minus 1 is 8. So that's 9 factorial divided by A factorial. Well, 9 factorial can be written as 9 times 8 factorial divided by A factorial. Well, A factorial divided by A factorial becomes 1. So this is just 1. 9 times 1, which is just 9. Okay, that's question 5. So I'm going to do another video for question for 6 until 14.